In this video, we are going to learn how to use molarity as a conversion factor. This is part of our learning objective for applying stoichiometric relationships to calculate amounts of substances in chemical reactions. So here's an example problem. It reads, what mass of FePO4 is formed? So I'm trying to find mass, which is grams, when 35 milliliters of 1.25 molar this reacts. So we are given 35.00 milliliters of that. Whenever you see this in a problem, that's a conversion factor. Molarities are conversion factors. They're not your starting value. That's because that represents 1.25 moles per 1 liter. So let's see. I'm given milliliters, and I know that this will be 1.25 moles of that substance per liter. So my molarity can help me be a conversion factor to get into moles. So my first thing I'm going to need to do is get into moles, and I'm going to use my molarity to do that. But my starting value is in milliliters. So I'm first going to need to get that into liters so that I can cancel out my liters. So I need to get out of milliliters. I need to get into liters. There are 1,000 milliliters in 1 liter. Now I'm in liters of this, and that's a solution. So I need to cancel out my liters of solution. And now I'm going to be in moles of that compound. So my molarity, I have to remember that liters is in the denominator and moles is in the numerator. This 1.25 is in the numerator, so that's the 1.25, and then the 1 is in the denominator. It's a little bit different than our molar mass, where the 1 is next to the mole amount. In molarity, the 1 is next to the L. Now I need to cancel out my moles of Fe2SO4, and I need to get into moles of the compound I'm interested in, which is FePO4. And so that's a 2 coefficient in front of that compound and a 1 coefficient in front of the other. And now I need to get out of moles of my new compound, because I always need to get into moles. That's my molarity. Remember, stoichiometry is as easy as 1, 2, 3. So I need to get out of moles. Moles, and I'm asked to find grams. So that's not going to be a molarity. That's going to be a molar mass, because grams per mole are the units of molar mass. So I see up here, the molar mass has been calculated for me. And so that's going to be the 150.816 number. Okay, so let's type this into the calculator. 35.00 times 1/1000 times 1.25 over 1 times 2 over 1 times 150.816 over 1. And so that tells me my answer is 13.1964 grams of FePO4. How many sig figs do I need? That had 4, that had 3, so I'm going to keep 3. And I'll round that to 13.2 grams of FePO4. Here's a practice problem for you. I want you to pause the video and try to work this out on your own, and unpause the video when you're ready to continue. The problem reads, how many liters of 0.115 molar potassium iodide solution is needed to react with 0.104 liters of a 0.225 molar PbNO3 subscript 2 solution? Okay, let's go over this. Let's identify what conversion factors we will need to get into moles, change compounds, and then get out of moles. So we're gonna, what are we given? How many liters? We're gonna put that. So we are given both liters and that. So we're gonna be using the molarity of the PbNO3, the lead nitrate solution, to get into moles. We're going to change compounds using the molar ratio, because that's how we always change compounds. And then we're going to get out of moles. We're going to get out of moles, and this time we're going to use the molarity of the other solution. Okay, so let's do this. I'm going to start way over here. So we are given 0.104 liters of the lead nitrate solution. I need to cancel out liters of that solution. And then I need to get into moles of that substance. Then I need to change compounds, so I need to cancel out my moles of PbNO3, and then I need to get into moles of what I'm interested in, which in this case is potassium iodide. And then I need to get out of moles, so I need to cancel out my moles, and I need to get into grams. Nope, I don't need to get into grams. I'm asked to find liters. So I need to get into liters potassium iodide. So going back in to fill in the numbers, based on the molarity here, I have 0.225 moles per 1 liter. Now I need my molar ratio. There's a 1 in front of the lead nitrate, and there's a 2 in front of the potassium iodide. And then I need to cancel out my, no. I need to cancel that out, but that's my molarity. When I use molarity, that value is next to the moles. So that's a 0.115 in the denominator. This means if you like, you can always erase the M and instead write moles per liter to help remind yourself that that number is attached to the moles. Okay, so now we can calculator this. So 0.104 times 0.225 times 2 divided by 0.115. I didn't type a 5, did I? Okay. So that tells me I have 0.406955 liters. And so let's see, how many sig figs? That has 3 and that has 3, so I'm going to need 3 sig figs. And so that would round to 0.407 liters of the potassium iodide. Here's another practice problem for you. It reads, aqueous sulfuric acid reacts with sodium hydroxide solid to produce sodium sulfate and liquid water. What mass of sodium hydroxide is required to neutralize 756 milliliters of 2.250 molar sulfuric acid? Then it gives us the balanced equation below. So go ahead and pause the video and try to work this one out. Unpause the video when you are ready to continue. Okay, so let's go over this. So I know that this is an acid-base neutralization reaction, and I'm given amounts of this. And so I'm going to be starting with the 756 milliliters. And then I need to find the amount of that. This is a solid, and it's asking for a mass. So we're asked to find grams. So 756 milliliters is 0.756 liters because you can divide by 1,000 in order to convert between milliliters and liters. And so that's my sulfuric acid solution. So I need to label that. Now I need to cancel out my liters of solution. And I need to get into moles of the solute. So that's going to be my molarity. Now I'm in moles, and so I'm going to use my molar ratio. So my molar ratio says that for every 1 mole of H2SO4, I'm going to be needing 2 moles of NaOH. Then I need to get out of moles. I'm asked to find grams. So I need to get into grams from moles. That means I'm going to be using the molar mass, because molar mass has units of grams per mole. I am not given the molar mass of sodium hydroxide, so I'm going to need to calculate that from my periodic table. So 1 sodium is 22.9, and then I'm going to need 22.99, add on an oxygen and 1 hydrogen, and so that is 39. Move my gram over. 39.997 grams of sodium hydroxide in every 1 mole. My molarity is given to me because I would need to know that. Okay, so now I have everything ready and I can type this into my calculator. And so that is 0.756 times 2.250 times 2 times 39.997. And then the denominator here are all ones, and any number divided by 1 is itself, and so I'm skipping all the divided by 1s and all the times 1s. And so that is 125.863 grams. And I'm going to need 3 sig figs because the 756 only had 3. And so that's going to round to 126 grams of sodium hydroxide. And I just realized that I mistyped this into my calculator. It's supposed to be A39, not A36. So let's edit that a little bit. So that's a 39. And so that changes my number to 136.069. I still need 3 sig figs, and so that's 136 grams of NaOH. Always good to double check that your calculator entry matches what's on your paper. It's very easy to mistype things sometimes.